Very good morning to you, dear students. Yesterday, we studied about momentum, change of momentum, and rate of change of momentum. We studied it to study Newton's second law of motion. So, today we will start with Newton's second law of motion. First, we will revise what is momentum. Momentum is the product of mass and velocity of an object. So, P is equals to m into V. Now, what does Newton's second law say? The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Now we have very well know what is the meaning of rate of change of momentum. So the rate of change of momentum is proportional to the what force we applied. It is directly proportional to it, and the change of momentum occurs in the applied direction in which we have applied the force. We will study about the derivation. Yesterday we studied rate of change of momentum. Same we will start with it. Suppose an object of mass m has an initial velocity u. When a force F is applied in the direction of its velocity for time t, its velocity becomes m. So, if a body is having mass m, initial velocity u, final velocity is v, and the time taken is t. So, what will be the initial momentum? It will be m into u, mu, and the final momentum after time t is m into v. So, rate of change of momentum is change in momentum upon time. Change in momentum means final momentum minus initial momentum upon t. We will substitute the values. Change in momentum, how to calculate? mv minus mu upon t. Students, m is common, so we can write v minus u upon t, simple mathematical logic. Up till this we studied yesterday, rate of change of momentum. Now can you tell me, can you recall this, what is v minus u upon t? Change in velocity in the given time, what it is called as, which physical quantity? Yes, it is acceleration. So v minus u, change in velocity in the given time, is acceleration. So a is equals to v minus u upon t. So instead of v minus u upon t, we can directly write a. So rate of change of momentum now is equals to ma. But according to Newton's second law of motion, the rate of change of momentum is proportional to the applied force. So rate of change of momentum we found out now, ma. This is proportionality sign, is directly proportional to the force applied, F. So F is equals to kma. This proportionality sign we can remove by writing the proportionality constant. But in SI unit, proportionality K is always equals to 1. So F is equals to, instead of K if we write 1, it will be F is equals to m into a. So now we had derived the formula for force, which is force equals to m into a. Hope you very well understood what is Newton's second law of motion. Here we derived the proof of force equals to mass into acceleration. Force is always measured in Newton. In SI unit, the unit of force is Newton. If force is equals to m into a, m is measured in kg and acceleration is measured in meter per second square. So this kilogram meter per second square is called as Newton. So 1 Newton, the force required to cause an acceleration of 1 meter per second square in an object of mass 1 kg is called as 1 Newton. So 1 Newton equals to 1 kilogram into 1 meter per second square. In the CGS system, the unit of force is dyne. Now what is 1 dyne? 1 dyne is the force required to cause an acceleration of 1 centimeter per second square in an object of mass 1 gram is called as 1 dyne. So 1 dyne is equals to 1 gram into 1 centimeter per second square. Here we completed Newton's second law of motion. Tomorrow we will study about Newton's third law of motion. Thank you.